Hello. Going to go over some of the homework on Section 6.5. Just a couple of questions because Section 6.5 is in some sense a review. So let me bring in the first one. Let's see here. I'm on page 473. And I'm going to do here question 234, so an even numbered one, so the answer is not in the back of the book. It says give a 99% confidence interval for mu1 minus mu2 using the paired data in the following table, and I'm going to copy it to the, although you have it in front of you, I'm going to copy it to the piece of paper nonetheless. So let's see how I do. So we're interested in the difference of the means, but we're interested here in these are going to be paired because they specifically told me it was paired. So I'm copying it down just to make it easier to read. So treatment 1 and treatment 2. Okay, and very quickly copying it down here, 2218, 2830, 3125, 2521, and finally 2821. They want me to take the differences, so I'm going to do the subtraction. Let's see how I do that. So 4, negative 2. So you got to remember the negatives. 6, 4, and 7. Okay. And once again, I'm sure there are some people who can get their calculator to tell them what is the standard deviation of those numbers, but I'm going to get StatKey to tell me. Just because I know how to do it with StatKey. So there we go. With StatKey, all I have to do is open this window and edit the data and enter the 5 numbers. So that's what I'm going to do. Here, what are the 5 numbers? It's 4, negative 2, 6, 4, 7. 4, negative 2, 6, 4, 7. I think I did that right. And it tells me that the mean is 3.80 and that the standard deviation is 3.493. Okay, I'll get rid of StatKey here, bring it back later when I need to do the t information. Okay? Okay, so a confidence interval, what do they want? A 99% confidence interval. So they want a 99% confidence interval. So we're looking at x bar plus and minus t star s over radical n. And n, again, this is, I know there are 10 numbers here, but n is going to be 5. All right, so I got to figure out t star. So over I go back to StatKey to get to the to get to the t curve. There we go. And I'm in the wrong place here, so I got to get out and I got to go down to the t curve. Degrees of freedom, I have not 10 pieces of data, but instead 5 pieces of data. So degrees of freedom is 4, all it remembers from the previous time. And now I want a 99% confidence interval, so I want to know what's the t associated with the middle of 99. So I'm entering 0.99, 0.99, and it says 4.606. 4.606. Okay, so 4.606, I'll write that down. 4.606. And I got to just fill in the rest. 3.493 square root of 5 plus and minus 3.80. I know we've done hundreds of these. I spare you the agony. I won't even bother to punch that out on a calculator. Okay, the 4.606 came from StatKey's t-curve, and the rest is just a question of adding, subtracting, multiplying, and dividing, and I guess taking the square root until you come up with an answer. So maybe I'll just suppress that. Okay, and then the other thing I wanted to do was a person who is saying to me, okay, so matched pairs means that I use a different circumstance here. I use the one mean circumstance. Well, when are things matched? So of course there's a question on the skill builder for when things are matched, and I wanted to go over those quickly. if I could. I think I not quite get them all on. It's close. And I know you can't read it all that well. This darn thing doesn't focus all that well. But anyway, so I'm going to read them to you. The instructions say determine which data analysis method is more appropriate. Paired, difference in means, that is to say matched data, or difference in means with two separate groups. So are you doing one mean or two means? So I'm going to read these through quickly and then just make a comment or two. I know the answer to some are in the back of the book, but I'm still going to make a comment or two. Okay, so to study the effect of sitting with a laptop computer, and some of these are silly, I'm sorry, I regard some of these as silly, but we're just going to go through them. Study the effect of sitting with a laptop computer on one's lap on scrotal temperature. Anyway, 29 men had their scrotal temperature tested before and then after sitting with a laptop for 1 hour. So this is before data and after data. So you presumably have an array with 29 rows. Each row of the array has a before number and an after number. So these are matched. Study the effect of women's tears on men. Levels of testosterone are measured in 50 men after they sniff women's tears and after they sniff a salt solution. The order of the two treatments was randomized and the study was double-blind. So it says you take 50 men and you have the men sniff the women's tears, and you also have the men sniff a salt solution. And sometimes one of them's first and sometimes one of them's second. They mix that up. And then they say, they say, what's the difference? So I think that's matched. I think for each man, my reading of this question is that for each man, there are two separate lines in that man's row. That man is a case, and there are two. Excuse me. That for that man, there are two entries in the array. There's a testosterone level when they sniff women's tears, and there's a testosterone level when they sniff salt solution. I don't know. Some of these I think are a little on the silly side. So matched. So I'm calling that matched and matched. In another study to investigate the effect of women's tears on men, 16 men watch an erotic movie and then half sniff women's tears and half sniff a salt solution. So this is, at least again, the way I read this question, is of the 16 men, 8 of them get women's tears and a different 8 get a salt solution. So there is no matching between the women's tears data and the salt solution data. They're just not matched. They're different sets of men. So for this, you would use two means. Section 6.4. Measure the effectiveness of a new teaching method for teaching math in elementary school. Each student in the class is matched with a student in a separate class on IQ, family income, math ability level, previous year reading level, and all demographic characteristics. I'm sorry. I think this one's a little silly too, because you can't match people perfectly. People are not. Anyway, we're going to go with it. At the end of the year, math ability levels are measured again. So I understand this to be matched because you match Johnny and Susan because they show up as pretty well fitted to each other from previous year's data. So I take this to be matched. It even says matched. In a study to determine whether the color red increases how attractive men find women, one group of men rate the attractiveness of a woman after seeing her picture on a red background, and another group of men rate the same woman after seeing her picture on a white background. So again, this is two different sets of men. They don't take sort of 16 men and sometimes show them a red, sometimes show them a white. Instead, they're taking men, and some of the men see a red, some of the men see a white. So there just is no match between the red numbers and the white numbers. They're just not matched. So this would be two means. This would be section 6.4. This one up here would be one mean. You would take, the students in class A minus the matching student in class B kind of thing. So you would end up with one single mean, and so this is matched and this is not. Okay, all right, that's where I'm going to stop. So leave the last one there, 45. So that's where I'm going to stop, and again, we're coming down near the end, so a person can have a little bit of a sense. At least I have a little bit of that sense. Okay, very good. So have a good day, and I hope everybody is well.